October 2025 will go down in history as one of the most active months in astronomical history. From the appearance of two naked-eye visible comets to the appearance of a mini-moon shadowing the Earth, to the close approach of 3I Atlas to the Sun, to the claimed discovery of evidence pointing to a possible discovery of alien artifacts lurking in archival footage from the Mount Palomar Sky Survey from the 1950s, years before Sputnik was even launched. This month is unrivaled in terms of astronomical appearances. Adding so much to our conversation in the public and in scientific communities is my friend Professor Avi Loeb, director of the Galileo Project, professor at Harvard, and all-around advocate for astronomical adventures. Avi is tireless, from his appearance just this past week on the Joe Rogan Experience for the second time, to his advocacy for Congress to loosen up the funding to protect and study these interstellar interlopers. Avi's unrivaled, and he gets a lot of negative feedback and hostility directed his way. We'll discuss that, some sniping that has been done towards him, and where do we go from here in our understanding of these mysterious objects, most notably 3I Atlas. All right, Avi Loeb, welcome back to the Into the Impossible podcast. How are you, my friend?
I'm doing great. A lot of things are happening. I woke up at 1 a.m. Today, so it's sort of late in the day for me.
Well, it's a special day for many reasons. I like to say that you were on the Joe Rogan Experience yesterday, or your episode came out yesterday. So that episode will be your second most popular episode this week, I'm sure, after this one, right, Avi?
Let's make it that one, yeah.
So we're going to talk about a lot of things today. We're going to talk about the anomalies that just seem to keep compounding, growing, like the national debt, this iceberg of cash, but it's an iceberg of who knows what, and maybe you know what, the 3I Atlas. It's really, I mean, I've been so impressed by how you've been humble about this object, because without you, I claimed on Twitter recently that no one would even care about this object. Now we're hearing about spacecraft that might be redirected. We're hearing about, people in Congress that want to pursue it, perhaps. We'll talk about all of that. We'll take questions from the audience as well. You have to be a subscriber, by the way, to the channel, at least. Channel members get special advanced, advanced priority on this. So it's joining the channel for 99 cents a month. It's a very small amount of money. But otherwise, if you want to ask a question, I will take it from the audience as well. And that'll come up later. But first, I'm going to start with a rather obstreperous tweet that I did see today, which came from a man, by the name of Brian, not me. He does spell it the same way. And it's Brian Cox, who today just wrote the following. Just to be clear, Avi, he wrote, given recent drivel online, Comet 3I Atlas is a comet made of carbon dioxide and water ices and bits of other stuff. It's entirely natural, Avi, in origin. Its orbit is as expected, and it'll whiz around the sun and disappear into the galaxy again. If it ever encounters another inhabited system, I hope they're more sensible than us. I don't know who he's speaking for. Not me, certainly. And I hope they'll enjoy it for what it is, a visitor from elsewhere, a pristine lump of rock and ice. Isn't that wonderful enough? So I won't tell you how I respond. I did invite him on, but of course he ignored me. But Avi, what is going on? What is your reaction to this rather provocative tweet from another Brian, but not me, Brian Cox?
Well, if we ever imagine a cave dweller finding a cell phone, the cave dweller would say it's a rock of a type that I've never seen before. That's pretty much the response of Brian Cox. Moreover, he is not a practicing astrophysicist. He is just expressing what sounds to him as the most likely explanation. He's trying to be popular. He's trying to not deviate from what people think based on traditional knowledge. And the thing about doing science at the frontier, actually being a practitioner, is that you allow yourself not to know the answer. You are guided by data. And if there are anomalies, you ask questions. You don't give answers. You ask questions. Why do we have these anomalies? He does not ask these questions. So the analogy I would make is that he is a commentator, okay? And myself, I am an actual player on the field. Imagine a soccer match and I'm playing on the soccer field, and he sits on the bench and comments about what he thinks the play is about. And the point is, he will never score a goal because he's not playing on the field. And that's what makes the difference between a practicing scientist speaking on a subject of research and someone who comments on the research as if he tries to represent the most popular view. And science is not decided by popular views. We know that for many centuries, it's decided by evidence. And the evidence shows 8 anomalies of 3A Atlas, and we just need to try and explain them. And if we can't, we should admit it. So when Brian says the trajectory is a very common trajectory, that's not true, because the previous 2 interstellar objects came at a large angle relative to the ecliptic plane of the planets around the sun. And this one came within 5 degrees of that plane. And planets are usually misaligned with that plane to within a few degrees. So it's as aligned with the plane as the planets are. And the question is why? And someone suggested, oh, maybe because it's coming from the disk of the Milky Way galaxy. But the disk of the Milky Way galaxy is misaligned by 60 degrees relative to the ecliptic plane. So that's not a good explanation. Another explanation that people suggested is that maybe we are looking only in the plane. The answer is no. We discovered Oumuamua, we discovered Borisov. They came at a large angle. This object is actually much bigger than they were by at least an order of magnitude. So it's much brighter. The surface area is 100 times bigger than the others. And so it's so bright that you could have seen it coming from any direction. And the fact that we found it in the plane, the ecliptic plane, is surprising. The chance of that happening at random is 1 in a few hundred. So you can't just say it's a common trajectory. And then the timing of its arrival to Mars and then Venus and Jupiter allows it to come within tens of millions of kilometers from those planets when they move around the sun with an orbit that is hundreds of millions of kilometers. So that also requires some fine tuning. And in addition, there were some other anomalies. We saw nickel with very little iron, never seen before in other comets. And we have seen a glow pointing towards the sun from this object rather than away from the sun, the way we see in comets. Again, never seen before. I mean, we do have optical illusions when there is a perspective of the observing a comet from the Earth gives us the illusion that there is a comet headed towards there is a tail headed towards the sun, but we've never seen a comet where a physical extension of the a tail was actually an anti-tail, was pointed at the sun. And in this case, there is no ambiguity because we saw it at a large distance when the Hubble Space Telescope imaged this object back in July 21st. And then more recently, of course, during the month of September, the anti-tail is turning into a tail. So it would be really interesting to get a hold of the image. The best image we have is actually from the HiRISE camera on board the Mars Reconnaissance Orbiter. That image was taken on October 2nd, 2025. And in fact, it was a set of images, maybe 4. They were not released because that was one day after the government shutdown. And NASA claims that they are not working and therefore they cannot release that data. This image should be 3 times sharper than the image from the Hubble Space Telescope, the best one we had so far, just because the object was very close to the HiRISE camera. And it's already almost a month since the image was taken. And I was corresponding with Representative Anna Paulina Luna today, and she promised to reach out to NASA in a message very graciously. She will try to convince them to release the data, at least to the scientific community. It doesn't need to be a press release that NASA authorizes. The data exists in the hands of scientists, for example, at the University of Arizona, and they are not affiliated with NASA. So I very much hope we will see that image because it will give us also, aside from the pixel size of 30 kilometers, it will give us a side view of the glow around the 3I Atlas because it was moving towards the side of Mars as it was headed closer to the sun. Today, the special day today is that it's closest to the sun, and we can't see it because it's hiding behind the sun relative to us.
So let's take a step back and examine what that means. So you have a wonderful article I recommend it to everyone. I'll link it in the description called "The Acid Test of Three-Eye Atlas," and this is why we're talking today, right? You're talking about perihelion. First of all, for those that aren't familiar, describe perihelion, aphelion, and what would happen to an object if it was a comet, as Brian Cox confidently asserts. He calls it Comet Three-Eye Atlas, which nobody calls it, right? No, nobody calls it Comet. They call it Three-Eye Atlas. It's a third interstellar object discovered by the Atlas program, a small telescope, half-meter across. You can buy it commercially online. But Avi, tell me, what would happen if it is a comet, and what do we expect to see, and when might we expect to see anything when it emerges from behind the sun? So first of all, what's perihelion for the non-experts? What types of effects occur on comets and on meteorites or other objects or technology around such a time as perihelion?
Right. So I should clarify what a comet is. A comet is a rock that is covered with ice that evaporates when it comes close to the sun. And then you see some dust and gas around it that gets pushed away from the sun by the solar radiation pressure and the solar wind. For example, the first interstellar object was also called a comet. It was Oumuamua back in 2017, and we didn't see any gas or dust around it. And so the comet experts called it a comet. Then they realized there is no evidence for a comet, so then they called it a dark comet, a comet where you don't see the signature of a comet, which is an oxymoron, actually. So it's not surprising that they would call anything a comet. It doesn't matter whether it has a tail, a cloud of dust or gas. They will always call it a comet. So I just ignore what they say in terms of the label they assign, because it doesn't inform us about the nature of the object. Now, a natural comet gets heated by the sun, and if it comes very close to the sun, then it can break up because it's glued together by ice. And you can have fragments of it flying out of it, and they have a larger surface area than the original nucleus of the comet, and as a result, it's a runaway process by which they absorb more heat and they break up even more. So you can imagine some fireworks. Some comets show fireworks as they come close to the sun, and they evaporate much more quickly, and they might actually disintegrate. So it would be really interesting to see if something like that happens in the case of Three-Eye Atlas. Now, the claim is it's made mostly of carbon dioxide. Well, in that case, carbon dioxide is much more volatile than water ice. And so whatever we see in terms of fireworks around the water-rich comets, which are the most common type of comets in the solar system, these are just dirty ice ball. And I should mention that Fred Whipple, who was actually at the Harvard College Observatory at the time, he went to Harvard Square on a winter day and noticed the students throwing ice balls at each other. And he realized, maybe he was the first one to recognize that maybe comets are just dirty ice balls, based on his experience at Harvard Square. And so indeed, they are made of rock and the water ice very often in the solar system. But this one, we see that the gas around it is made mostly of carbon dioxide, 87% by mass, and 9% is carbon monoxide, and only 4% is water. So in that case, it should have evaporated very quickly as it comes close to the sun, and we should see it potentially disintegrating. That's in the case of a natural comet, natural object made of carbon dioxide. And that would obviously tell us that it's natural. However, if it's artificial, if, for example, the nickel that we see without iron around it implies that it's a nickel alloy that was manufactured industrially, the way we manufacture the surfaces of spacecraft. In that case, of course, it could survive without anything unusual happening to it, and nothing dramatic will change, except that it may use the closest approach to the sun, which is perihelion. So perihelion is the point along the path which is closest to the sun. So if the path is carved just by gravity, it represents the midpoint of the passage of the object through the solar system, because the trajectory is symmetric. The object enters the solar system and then comes out in a symmetric pattern around the sun. And so the point of closest approach is the half point of the entire history of the passage of the object through the solar system. And if it's technological, it may not be the end. It may not be half of the path, because it could break, for example, or it can accelerate. And the best time to perform a maneuver is actually when it's moving fastest, because then you apply the thrust either in the direction of motion, so you get a boost, the largest boost that you can get, or opposite to the direction of motion, and you get a slowdown, a reduction in the kinetic energy. And in both cases, that's the optimal point of doing it. At perihelion, we use it for gravitational assist by a massive object like the sun with our spacecraft. So if it's technological, it might actually slow down or speed up, depending on the plan, or it might release mini probes that do that, because even for them, it's beneficial, energetically speaking, to do the maneuver just when they are closest to the sun. So that's what we should be looking for. And I should say the Galileo project that I'm leading established 3 observatories monitoring the vicinity of Earth for any anomalous objects. And I told the research team to search in the coming months if there is any unusual activity. In fact, one of the observatories was just constructed over the summer 2025, and it's on top of the Sphere in Las Vegas. I announced it at the Joe Rogan podcast. This is an amazing place. It's a sphere that is 130 meters high, and we went all the way to the top of it, and now it has a freckle on top of it, which is our array of cameras looking at the entire sky for any anomalous objects. And we have 2 copies of that array, that observatory, located 10 kilometers away. So we are able to triangulate, to look at an object in the sky from different directions and figure out its distance, its velocity, its acceleration, and ask whether those lie within the performance envelope of human-made technologies. So if we see anything unusual, you will know about it. I also encouraged in my exchange with Representative Luna today, I encouraged NASA to check what is happening on Mars. I mean, they have cameras on the rovers, like the Perseverance rover, and also they have the HiRISE camera on board the Mars Reconnaissance Orbiter. So those can be used to monitor Mars and see if there is any unusual activity there as well.
Hey everybody, I'm usually the one that asks my guests to judge their books by their covers, but today I'm asking myself to judge my own book by its cover. My newest book, Focus Like a Nobel Prize Winner, is chock full of advice, life tips, and focus and productivity tips from 9 of the world's greatest minds, Nobel laureates ranging from economics to peace to physics, of course. It launches September 9th, which is also my birthday. I hope you'll check it out. And my publisher's gotten Amazon to run a special just for listeners of the Into the Impossible podcast. You can get the Kindle edition for only 99 cents. That's less than a new pocket protector. So go to Amazon and get the Kindle copy today, because this special only lasts for the first week after launch.
Okay, so I want to know, the solar flux that you talk about is about 770 watts per square meter. Is that enough to vaporize, kind of the weak volatiles, the ice and so forth on top of a normal comet? Let's give Brian Cox, the benefit of the doubt. Although I said, he wouldn't maybe give it to us, but let's say it is Comet 3I Atlas. Nobody calls it that, but him. Would it do something interesting? Was that level of solar irradiance, is that enough to vaporize weak ices?
Oh, definitely, because that's inside the orbit of Mars around the sun, and we know that Mars had liquid water on its surface early on, and obviously it lost its atmosphere, so all of that evaporated. So that means Mars is a desert as a result of all the ice that was exposed to sunlight evaporating. So obviously something within the orbit of Mars will do the same for water ice. But here we are dealing with carbon dioxide, which is even more volatile than water ice. And so I would expect significant enhancement in the evaporation rate for carbon dioxide ice.
So you mentioned, the potential of mini probes. I mean, everybody loves to talk about that, Avi. I mean, the New York Post, Joe Rogan, is a really thrilling thing to contemplate. And between the last live stream we did in early October, when it was closest to Mars, and then today when it's closest to the sun, there's been this paper by Beatriz Villarroel, who's agreed to come on my podcast. Maybe we'll get you to join at the same time. In the coming weeks, she's kind of burned out, she told me, from all the media exposure she's getting, which is well deserved. But these are, kind of reports of glints of objects that are kind of like maybe mini probes, maybe not so miniature, in the 1950s, pre-Sputnik. What are the observables? Are they optical flares? Are they glints? Are they infrared excesses? What would you see if there were technological breadcrumbs, as you call them? What would you expect to see, and how could our audience, understand what sorts of signatures would be differentiated from just normal volatiles breaking apart and stuff like that, normal cometary behavior?
Well, if you see objects as satellites of Earth, there weren't any satellites that were human-made back in the 1950s until Sputnik was launched, and therefore it would be clear indication of technologies that humans did not develop yet. However, I should caution that the only way to be sure that something like that existed is to observe it from two different telescopes, because it may be, from one telescope you might have some artifacts. In particular, we're talking about photographic plates, and you could have defects in those plates that would appear as a glint or as spots of light, but they are not real. And these defects might be even clustered, might be sensitive to the level of illumination. So in principle, you might have more overlap of those with the shadow of the Earth. That is one method that was proposed by Beatriz to identify real objects if they don't glint when they are in the shadow of the Earth. But you could have, within the plates, you can have clusters of defects that would give you statistical significance that has nothing to do with the sky. It has to do with the plate itself. So we have to be careful about that. And the only convincing clue that I would definitely believe with no doubt is if we had the two separate observatories seeing the same object in the sky at the same time. So in addition to the Palomar plates, there is also a collection of the Harvard College observatory plates. And that was digitized, actually. And I did speak with the person who digitized it, Josh Grindley, today and a week ago. And we are planning to check if the same type of objects that were reported appeared in these plates as well. We know the time, we know the coordinates, so we can check that. That would be conclusive evidence as far as I'm concerned. Otherwise, I would be always suspicious that there might be some defects in the photographic plates that are difficult to model, because these are old technologies. And my approach in general is not to rely on past reports, but instead collect data that is verifiable with present-day instruments that are far better than we had back in the 1950s. The complication is that human-made objects are more abundant now in space, so we need to differentiate them. But that's why we have machine learning, artificial intelligence that allows us to filter out familiar objects that are human-made, and especially not just in terms of their appearance, but also in terms of their trajectory. And that's what we are doing with the Galileo project, the observatory, especially the observatory in Las Vegas, that would be extreme state-of-the-art and extremely interesting to use.
But why was it put there? I mean, I wouldn't think for light pollution reasons I'd put anything optical there, but it must be looking for things other than visible light spectrum and signatures thereof.
Yes. So we are using an array that is sensitive to the infrared, and we actually tested it, and that can be used at nighttime, and we found that there is not much light pollution for that array of cameras. So we are already have we are analyzing data, and we are expecting a few million objects per year that we will examine. And we could, in principle, figure out, even if there is one that happens to be outside the performance envelope of human-made objects, we will be able to find it. Altogether, I'm doing this because even if we don't find any extraterrestrial technological object, the techniques that we are developing in terms of sensors, in terms of the machine learning software that we use to analyze the data, those can be used by the Department of War for national security purposes. So it will never be wasted. Whatever we learn can be used to search for human-made objects like drones that, of course, are an issue for the Defense Department, and we need to develop better tools than were used in the past.
So when we look at the potentiality to differentiate between the volatile gases, things breaking apart, I mean, this is such a crucial time because it's getting so close to the sun, and that's when the maximum activity would occur for a normal object. But as you said, it could have these features. It could, potentially. Although you put out, I have to ask you, did you convince Harvard to divest their endowment yesterday? I mean, did you personally take any activities like you claim that might be prudent to do with your portfolio?
No,
did you do anything yesterday?
No, so I'm very much of the opinion that this kind of situation is very different than what you encounter usually in the context of science. Because suppose you are searching for B-mode polarization from cosmic inflation, just as a random example, okay? And suppose you detect it, there are no implications to the person on the street in terms of their daily life.
Right.
But if we are dealing with a visitor to our backyard, like 3i Atlas, and it happens to be technological, even if you assign a very small likelihood for that to happen, the implications would be huge. Yes. And that means that we have to consider that possibility. That is well known within the intelligence agencies. These are called black swan events. These are events that have small probability but a huge impact on society, and therefore they must be considered. And actually there are protocols and scenarios for such events, and that's why it costs so much, $1 trillion a year in the defense budget for 2026, because you have to deal with a lot of risks that have low probability, but you must collect a lot of data in order to figure out whether they are real or not. And so that happens all the time. We are putting a lot of money into risk assessments that end up not being a risk eventually. And in the same way that when scientists are investing $10 billion in the Large Hadron Collider and we don't find supersymmetry, we just move on. Nobody would say it was a waste of effort or money. And the same is true about the intelligence agencies finding scenarios that do not materialize, but they at least had checked and avoided the risk that the society otherwise would not be prepared for. Nice. Now, this situation with a visitor from interstellar space is that kind of an event. It's an event that has potentially a huge impact on humanity, and therefore we cannot ignore the possibility that we are being visited by a technological object. Even if you say the probability is small, you can't as a scientist say, I will just abide by the most likely scenario, and even if there is a 10% chance that it's something else, I would prefer to stick with the 90% because then I don't risk my reputation. Well, it's not about your reputation. It's about the future of humanity, okay? So if there is a 10% chance of it being something different than a rock, we should invest huge resources just to figure out that it's a rock, just to make sure, and we should not speak about it as a rock before we have the full evidence.
Yeah,
so it's not about preserving our image, being correct, showing off as if we know the answer in advance without much data. It's not about that. It's exactly the opposite. We want to be absolutely sure, using all our assets to figure out the answer. And by the way, just before I joined you, I did a very interesting calculation because I have interviews nonstop right now.
Yeah.
And one of the interviewers asked me, would it be possible to image 3i Atlas with a radar system? And in fact, we used radars to image asteroids that came close to Earth. And I did a simple calculation. The flux of reflected radio waves from an object scales as the diameter squared of the object, as the area of the object, and inversely with distance to the fourth power, because there is a 1 over distance squared change in the flux impinging on the object if you transmit it from Earth.
Yep.
And then another 1 over distance squared for the flux that you detect bouncing off the object. So altogether 1 over distance to the fourth. And I calculated that, in fact, 3i Atlas is right now, or over the past week, would have been within 50 million kilometers from Earth if Earth was at the point where it used to be 6 months ago, or will be 6 months from now. So on the opposite side of its trajectory, at that distance of 50 million kilometers, we could have used existing radar systems to image 3i Atlas. In other words, measure its size directly and also get an image of it as it rotates every 16.16 hours. So it rotates every 16 hours, and we could have seen a three-dimensional map of how it looks if we only could have been 6 months ago at the point where 3i Atlas is right now. And the unfortunate fact is that it avoided us. And the question is whether that was on purpose, because we would have solved all mysteries by having an image of 3i Atlas if we only were 6 months back in time.
Well, I mean, you're too humble to admit it, perhaps, but you've been highlighting the importance of this for the better part of this year. I mean, we first started talking about it, briefly early, late in the spring, of 2025. That was plenty of time. And you had the ear of, Congresswoman Luna and Burkett and other people. I did try to get them on the show today. They're busy. I don't know what they're doing, with our non-existent tax dollars as the government is shut down, which I claimed last time was the 9th anomaly. You're sandbagging it, Avi. You only talk about 8 anomalies. Add in the fact that the aliens knew that the government would be shut down in America. We couldn't have NASA.
I should say that it's not a sign of extraterrestrial intelligence. The shutdown is a sign of terrestrial stupidity.
That's right. And so, they're probably wisely, if they're smart, they'd be ignoring us and avoiding us. But let's talk about that. The trajectory of this object is hugging the ecliptic. It's threading close to Venus, Earth, and Jupiter, and Mars, as you said. What is the coincidence? What's the probability of this object, or have any other objects done this? Even normal comets, Avi. Forget about, let's assume Brian, the other Brian, is right. Brian Cox. And it's just Comet 3i Atlas. Avi, how many comets do what Comet 3i Atlas has done?
Very few. So first of all, only 1 in 500 would come on a retrograde trajectory that is within 5 degrees of the ecliptic plane. So because the comets originate, at least the long period comets are coming from the Oort cloud, which is roughly spherical around the sun. And that means they come in all directions. So 1 in 500 will come as close to the ecliptic on a retrograde orbit like this one. And then there is the timing. It needs to come at the right time, at the right place, to the vicinity of Mars, Venus, and Jupiter. Now, some people say, well, it avoided the Earth, but I see that as a signal because maybe it did it for a reason. But at any event, just to come so close to 3 planets requires a chance in 1 in 20,000. That's based on the fact that the orbit of those planets around the sun is spanning a much larger distance. So for them to be within tens of millions of kilometers from 3i Atlas when it's there requires a very fine-tuned trajectory. So that's another peculiarity of this object, and it will never go away. So it doesn't matter what Brian Cox says. I should also say that we can maintain our ignorance by saying we know everything, even though there are anomalies, but this is the recipe for not learning something new. And whether we have a neighbor or not does not depend on what we say about the neighbor. Just think about yourself living on a street and you tell your family members that you don't have a neighbor. Does that matter? No, the neighbor exists irrespective of what you tell your family members. So it's really not really helpful for us to say we know the answer in advance, therefore we shouldn't talk about additional alternatives, because it makes us lazy. We are not collecting as much data as we can. And One thing I should say is that since the last time we spoke, I wrote a white paper to the United Nations as well as to the International Astronomical Union, encouraging them to establish a committee that would coordinate observations of objects like 3i Atlas, collect as much data as possible, and inform policymakers, politicians. And 2 weeks after I submitted this white paper to the United Nations, an organization that is affiliated with the United Nations called the International Asteroid Warning Network, IWAN, they issued an announcement by which they said that they are coordinating a campaign to get as much data as possible about the motion of 3i Atlas between November 27th and January 27th. So that would be really fantastic. I salute this initiative, and because as far as I'm concerned, the biggest crime we can commit is not collect as much evidence, as much data as we can, given all the assets that we have. Because this is a gift from interstellar space. It comes in the ecliptic plane, spends months, a long time, close to observatories that we have. So we will never have such an amazing opportunity if this is a random trajectory, by some natural comet. Why would it come close to planets where we have orbiters? Why would it come in the ecliptic plane, so it spends a lot of time close to, in a relative vicinity to our observatories?
Talk about the anti-tail, because that was relatively new, and that was completely unexpected. I mean, if you also add upon, kind of surprise, paradox, anomaly upon anomaly, yes, it's circumstantial, but enough circumstantial evidence can be used to convict. So let me ask you this question. Anti-tail, what do you make of that, and how anomalous, how unusual is that? I heard, from commentary, quote unquote, experts. It's funny because you are the nexus of all these people that study, biosignatures, technosignatures, comets, minor planets, exosolar planets, exomoons, and they're all basically, kind of riding your commentary coattails, I should say, or they all get really interested in this, but they never predict or presage or preempt what you're going to say. So they're very reactive, and maybe that's fun for you. I don't know. But then the anti-tail, I mean, that really must have flummoxed a lot of people besides you.
So it's not a perspective effect. It's not a matter of our geometry.
Well, first of all, what is it, Avi? Explain to the audience that might not be. Yeah. What's an anti-tail? What's a tail?
So the reason it's called anti-tail is because a cometary tail usually points away from the sun, because the dust and gas gets pushed by the solar radiation pressure and the solar wind away from the sun. So there is a force acting that resists the motion of those dust particles and gas particles, while the nucleus of the comet continues unhinged, and it just has much more mass per unit area. So it's just like a bullet moving through, but then the gas and dust gets pushed behind it away from the sun. And therefore, we should always see a tail pointed away from the sun. Sometimes the Earth is at a vantage point where the perspective gives us the false impression of an optical illusion, as if there is a tail towards the sun. So people reported situations like that, but that was just a matter of perspective. And for all the comets that I know about, there is always, obviously for the physical reason of the sun pushing the material away from it. It was always extended away from the sun relative to the nucleus where it's coming from. However, for 3i Atlas, during July and August, it seemed like there is a glow that is pointed towards the sun, and it was like a jet. In fact, the Hubble image was twice elongated in the direction of the sun, but we looked at this elongation almost head on. So if you think of a cigar, we were looking almost along the long axis of the cigar. So it was actually a jet that was 10 times longer than it was wide. And we just saw it from a perspective of the edge of it, because the misalignment between the direction of the sun and the direction of the observation from Earth was just 10 degrees at that time. That was back in July 21st, when the Hubble image was taken. So what was the reason for this jet 10 times longer than it is wide towards the sun. And of course, the folklore of people who work on comets is to just ignore it and say, well, there are lots of peculiarities of comets. We don't need to understand it. So I wrote 2 scientific papers with Eric Kito trying to explain the physics behind it. And the standard approach that is taken by people who don't do any calculation is to claim, oh, these might be dust particles that are very big, let's say a millimeter or a tenth of a millimeter in size, so that the surface area per unit mass is much smaller. These are big chunks of dust, not tiny dust particles. The point to keep in mind is, in that case, they would not scatter sunlight very effectively, because to scatter sunlight, you basically need the particles with a size comparable to the wavelength of visible light, which is half a micrometer. And therefore, if you make particles of hundreds of micrometers, they will not scatter very effectively. You will need to shed a huge amount of mass in those in order to get the same effectiveness in producing a glow of sunlight. And in my paper with Eric Kito, we propose that, in fact, there is not much dust, fine-grained dust, but it's mostly ice that is being shed off the object, and the ice fragments, they just eventually evaporate, so they don't turn around. And that's why you see a jet pointed towards the sun from the sun-facing side. As to the nature of the object, don't, as you often say, don't judge a book by its cover. What we see in terms of the ice evaporating from 3I Atlas tells us about the skin of the object. I calculated that it's only a layer that is somewhere between a millimeter to a centimeter thick that was evaporated over the past 5 months. So not much. And the object is 5 kilometers. Just think about the size of the palm of your hand compared to the size of Manhattan Island. That's roughly so from the thickness of the palm of your hand, you can't really tell what the rest of the object is made of. And we know that it's losing about 150 kilograms every second based on the Webb telescope data from August 6th, 2025. And I calculated how much recoil the object may get. And it turns out we don't see any recoil of the object. It follows a perfectly consistent trajectory with gravity alone, no non-gravitational acceleration. And for that to be the case, the object must be very massive. And I calculated that it's at least 33 billion tons in mass, or for solid density, it's about at least 5 kilometers in diameter. So that's a very massive object. That was the main issue that I had with the object being natural, because why didn't we see, it's a million times more massive than Oumuamua. Why didn't we see a million objects like Oumuamua before we see a giant one like this one?
And what about the metal ratio uncertainty and how anomalous that is? Have we learned more since just this? It's fascinating. And again, everybody out there, Avi's got his haters. We all know that they're trolls. We don't want to feed the trolls, as I often say. But Avi, everybody's interested in this from the metallurgical perspective, from the compositional perspective, from the kind of archaeoastronomical perspective. Obviously, technosignatures, biosignatures, all sorts of things. All this, you're at the center of this firestorm. And of course, you take it upon yourself to go on the second most popular podcast after this one, The Into the Impossible. You go on to Joe Rogan's yesterday, and you've got a race car with your likeness on it. But Avi, tell me, what have we learned in just a short amount of time, which, by the way, is completely unprecedented in my 30-year scientific career. Yours a little bit longer. You could be my cousin. You're a little bit older, but not much. But Avi, this is unprecedented. The amount of information arriving about this object, I think it's 90% due to you. There's a lot of great scientists working on this problem. I don't want to minimize what they're doing. But the attention that you're getting to this object that it rightfully deserves should be a credit to you, and you should be getting a lot of kudos. You're not, but you're thick-skinned. But Avi, what have we learned about the composition, the metal ratios? Is it like these meteorites that people can win if they enter in my my Monday Magic mailing list at briankeating.com/YouTube or YT rather? Please tell me, what have we learned about the composition compared to these meteorites, which I can give away to my audience? They're so interesting.
Well, first of all, the existence of nickel or iron in the plume of gas around the comets is not well understood because the temperatures are not high enough to release these materials. And but putting that aside, during the month of August, we detected mostly nickel, no iron. There were actually upper limits on the iron, and that implied a very extreme nickel to iron ratio, never seen before in comets. And the only place where we see that is in nickel alloys that are produced by our industries, partly for aerospace applications. And that is produced through the carbonyl channel pathway, where there is a process by which you isolate nickel from iron. And what was said by the authors of these papers is that this is really peculiar to see nickel without iron, because usually they appear together. In fact, in the solar composition, there is more iron than nickel. And perhaps in nature, there is a process similar to that, the one we use in industries, the carbonyl pathway. Maybe it operates in nature. So they are using what we know from our industries to argue that nature may employ the same process and say, okay, well, maybe this is the reason why we see nickel without iron. But to me, the argument is the only place we saw it is in the context of industrially produced nickel alloys. Well, maybe it's technological in origin. I mean, at least it's an interesting hypothesis. And of course, Brian Cox is not even aware of that, I guess. And to me, it's all about the data. You know, the interpretation has to do with what we know about the object. We have to learn from the data about the nature of the object. And even if it's natural, it would be really a peculiar natural object of a type that we've never seen before. So let's do the best we can to learn about it. I would also advocate a new frontier in astrobiology, which is to contemplate an intercept mission with future objects. We could have done it with 3I Atlas. For example, the Juno spacecraft, if it carried the initial fuel that it had, it could have maneuvered right now so that it meets 3I Atlas when it comes closest to Jupiter on March 16th, 2026. Unfortunately, the Juno team used most of the fuel, so it can't do that. But that shows that it's feasible. If you detect an interstellar object early enough, you can intercept it.
Another thing I love is that, people started to complain, oh, Avi, that's unrealistic. We can't repurpose Juno to do this. But my idea is to purpose, to look at an asteroid. So in other words, they wouldn't have thought of that, is my claim.
No.
Without you kind of suggesting this.
If we ever intercept an object like that, we can bring a sample back to Earth. And that to me is a new way to learn about the building blocks of life near other stars. Even if it's a rock, we can study the materials that took millions to billions of years to arrive to our backyard. This is a rock that came from a neighbor's yard. And instead of just looking at the atmospheres of exoplanets, trying to infer whether they have oxygen, methane, water molecules at a cost of more than $10 billion, which is the current favorable plan, the highest priority of the astronomy community, to just look for these fingerprints. I say here is a path for astrobiology that is completely different, which is to collect a sample from a rock that arrived to us from a distant star and check whether it has the building blocks of life as we know it, or maybe even some microbes that survived. We have to look into that. And that was never contemplated before. And given the opportunity we see with 3I Atlas, it may be feasible in the future. And at a cost of $10 billion, we might be able to do such a sample return mission. So it's just another path for astrobiology that was never thought about before.
Now, in addition to that, Avi, I have to say, in particle physics and even in cosmology, we demand 5 sigma significance before we declare something a discovery. My late great colleague Hans Parr used to joke, at 3 sigma they'll invite you to do a lunch seminar. They may pay for lunch, they may not. 4 sigma you go to a colloquium, and 5 sigma you go to Stockholm. And you definitely get paid to do that. So let me ask you this question: what would be the 5 sigma moment? I mean, what would it take to convince you and convince the world, assuming that they're rational actors, that you're right?
Yeah, it's very simple. Well, if we were 6 months ago close within 50 million kilometers from 3 Atlas, right now, we could have imaged it with a radar system. we could have learned about its shape. And the shape would have told us as it rotates whether it's technological or natural. But in addition, of course, if you have a camera that you fly close to it, you can image it, and that would be as good as the radar system. Finally, the cleanest signature right now for me, it would be a maneuver, if it were to maneuver or emit a radio signal. So I got a confirmation after contacting radio observers. I got a confirmation yesterday that indeed they would allocate significant time and use major facilities to check for any radio transmission from 3i Atlas. And that, of course, reflects the fact that I noticed that the direction of the WOW signal from 1977 was within 9 degrees of the arrival direction of 3i Atlas. And in order to generate that signal, from a distance of 3 light days or 600 times the Earth-Sun separation back in 1977, 3i Atlas had to transmit a radio power of about 1 gigawatt, which is roughly the power output of a nuclear reactor on Earth. So it's not outside the scope of technology, and especially when dealing with a spacecraft that is, at least 5 kilometers in size. The biggest rocket that we produced is Starship, and Starship is less than 100 meters. So we are very far from any prospect of launching an object that is at least 5 kilometers in size, and obviously we'll need to produce a lot of power on such a spacecraft. The interesting question is whether there is any transmission, and again, it's not Brian Cox who will tell us, it's actually the radio observers who will tell us. So,
I do want to, come to well, first of all, we're going to get to audience questions from members only. I'm going to try to parse my list here, but we've got, 5,000 people are watching right now, Avi, and, Joe Rogan, eat your heart out. But the kind of philosophy that I adopt is, obviously the risk analysis kind of philosophy, which is one of, avoiding making false alarms, but also not missing our next opportunity. So these go by the name of type 1 and type 2 errors. I want to ask you, given the different weightings and consequence, would you rather have cancer and be, and be told you don't have cancer, or, not have cancer and be told you do have cancer, right? These are the different types of errors. But getting ready for the next one. I mean, you and I have talked about, 2 of these objects. There's only been 3, but only in the last, 5, 6 to 7 years that we've really had our eyes open. We're going to see many, many more of these. You've that.
And
so what do we do next? Before we get to that, what do we do next time? Are we going to talk to Musk? Are we going to talk to Congress? Are we going to talk to NASA, ESA? Who are we going to talk to so that we don't have a Juno depletion of its fuel for maneuvering? What do we do next, Avi? What's on your dream list so that we don't make a type 2?
My hope is to speak to the President of the United States and inform policymakers of the potential risk, the technological risk, also including Congress, and make a plan. The plan would be to collect as much data as possible. And right now we have the Rubin Observatory in Chile that monitors the southern sky. And at a cost of less than $1 billion, we can build a copy that will monitor the northern sky. We need to cover both hemispheres. And that will be a warning system. If we ever detect a technological object coming from outside the solar system, then of course we can go to the next phase, which is to invest $1 trillion a year in putting an alert system in the outer part of the solar system. That means telescopes, observatories that are not on Earth, but out there, that will warn us in advance, as well as interceptors. And with $1 trillion a year, which is a fraction of the global military budget, we can do that. But I don't anticipate that happening. I mean, the money exists, but it's not. It's allocated to military purposes right now. But once we realize there is a threat from outer space, we might allocate a significant fraction of the military budget to that task, and that would mean a factor of 1,000 more investment than we currently have. That we had in the Rubin Observatory, and in fact every year perhaps. So I do see that this will become a major issue for the future if we find after the first encounter, right? And the issue is, let's make sure that I hope that the first blind date that we have with a technological object will not be with a serial killer. That's really the hope that I have, that we will survive that first encounter only to learn the lesson of looking for similar objects later on. I should say that it's not only that there is a lot of interest in this subject in Washington or in the general public. I was surprised the day after the interview with Rogan, I was invited to a car race, the NASCAR car race in California, and I went there, and one of the drivers there put my image along with 3i Atlas on the hood of his car, and he also showed me how to drive a race car, which was a very interesting. They move really fast, but I told him your car will never will always be at least 600 times slower than 3i Atlas. So for 3i Atlas, it's not a great compliment to have its image on a car that moves 600 times slower. Of course, my image for me was a great compliment. And I should say it's a very different culture. These are not people who are very much familiar with academic thinking. They are car
country
racers.
boys. This is my crowd. The country boys. They can survive.
Exactly.
The fate.
And I really enjoyed being in their company and learning how small changes in the shape, the aerodynamic shape of the car, can make a huge difference in the race. And with me was the Netflix documentary team that follows me for more than 3 years now, and they hope to release their film in 2026. So you might be able to see actually the footage from that car race. And
who's going to play you, Avi? Who's playing you in the movie? No, I'm joking.
Oh, indeed.
I know it's you. I know it's you.
But I should say that I did meet Jerry Bruckheimer in an event, and after I gave a talk, he came to me and said, I just produced F1, and he. And now I'm having the next project on scientists seeking unidentified anomalous phenomena. So a few minutes after that, I met Adrian Brody, and he told me that he was really excited about science at a young age, but ended up as an actor. And so I went to Jerry and said, why don't you pick Adrian for the key role of a scientist? Of course, it's not up to me to decide about the cast.
Yeah, exactly. Okay, we're going to get to audience questions. So start putting some questions in the chat on YouTube only. I'm only taking YouTube questions because I want to reward my members and subscribers there. You have to be a subscriber. Bonus points if you become a member. And by the way, this stream will be taken off as soon as we're done. And we have to do, we'll do some value add to it, so it'll disappear for a little bit, but we'll bring it back. Don't worry. So I do want to ask some questions. Before we get there, though, I want to talk about the null hypothesis. Always have to be aware of the null hypothesis. It could be a Coxian comet, right? What are we going to learn about comets? To give Brian, again, the devil is due. He's not a devil, but to give the devil his due, so to speak, devil's advocate. If it is one of these miraculous, things that are natural comets and so, what have we learned about this cometary object, if indeed it is a comet? What mysteries has it raised about comets, if indeed, again, it's not technological, but it's certainly interstellar? What do we learn about it?
So I actually wrote papers on each and every point that I will make. One is the high speed of this object. It was 60 kilometers per second outside the solar system. And together with my undergraduate student, Shokruz Kakarov, we integrated the trajectory back in time through the galactic potential, the gravitational potential of the Milky Way galaxy. And we concluded that it must have originated from the thick disk, meaning that the population of old stars around the disk of the Milky Way galaxy, they were steered over a long period of time by passing objects, by passing dwarf galaxies that join the Milky Way and so forth. So the old stars have a much larger velocity dispersion than the young stars that are born in the thin disk out of molecular clouds. And we found that this object must have originated, if it's natural, from old stars that are older than the sun, perhaps 10 billion years old. And so that's one thing you would know about the origin. We don't know which star, of course, because we don't know how long the journey was. And the second thing is it's made presumably mostly of carbon dioxide, and then so that must have formed in the so-called ice line of carbon dioxide, which is farther away from the star, the birth star, the parent star, than the water ice line, where we found our comets to have been made. So in the solar system. So this was an object that was made in the carbon dioxide ice line around the parent star. The question is, why is it so massive? So unless we find that this object is less than a kilometer in size, there would be a problem with the mass budget. I did that calculation in the first paper as soon as the object was discovered, and I showed that there is just not enough mass in ejected solid material from planetary systems to account for the delivery of a 5 to 20 kilometer object, solid object, over the past decade. You would expect it to arrive to the inner solar system once per 10,000 years. It's very rare. And so we will have a problem with the mass budget. Again, this is a problem not only that Brian Cox ignores, but all the comet experts are not discussing it much. There was one discussion by Daryl Seligman about it. And so I see that as a serious issue. If this object is indeed much bigger than 1 kilometer, then there is a mass budget issue. And it will teach us that there are much more prolific factories of objects like that than we imagine based on what we know about planetary systems. So again, the origin story is unusual here. Finally, we would have to explain the nickel versus iron, and that is still an unresolved problem, even in the context of regular comets. So we will need to come up with an explanation. And for the initial anti-tail that we discussed before, the question is, was it a result of large dust particles, like much bigger, at least, if there are 100 to 1,000 times bigger in size, as some comet experts are arguing, there are 1 million to 1 billion times more massive. So you need to say those dust particles are up between 1 million and 1 billion times more massive than the typical dust particles that scatter sunlight. And that means that you have to release a huge mass of dust out of the 3A Atlas. And
talk about, Avi, I was curious about the fact we talked about the anti-tail, which is anomalous, but then it turned into a tail. Have we ever seen that kind of behavior before in an ordinary comet?
No. So it's all, and I decided to write 2 papers about it, trying to explain the physics, because, whatever is released from the object must follow the laws of physics. And we wrote those papers with Eric Ito. I should say the editor, when we submitted one of them to a journal, the editor said, this subject may not be of great interest to the wide astronomy community. And so then we submitted to another journal and got a very favorable report. And I just want to emphasize that, because I don't know how often you experience that, but whenever you are trying to write a significant paper, you get a lot of resistance. When you just write about a nuance of something that is already known, and you especially cite a lot of papers so that the referee is being cited in your paper, then the paper sails smoothly through the refereeing process. And that I find as a problem, because we are supposed to seek new knowledge in science. And instead, what happens in the scientific culture of today is that new knowledge is resisted. We don't want to hear new ideas. We don't want to discuss new possibilities of explaining anomalies. We just want to stick by what we already know. And that's really unfortunate for an editor to claim. And I know the editor because they identify themselves. That editor is not very accomplished. That editor is a second-class scientist, and of course, from the point of view of someone with traditional thinking, we shouldn't attend to anomalies. Why should we? We can just say that comets are strange, and that would resolve it. Each comet is unusual, and that's it. We don't need to explain why the anti-tail exists. And I find that to be anti-scientific, because whenever you see something you don't expect, you should explain that. And maybe you learn something new in the process. But if you don't imagine something new, then you will never need to explain anything, and you just ignore it.
Okay, so everybody get your questions there. Also, go to my website, briankeating.com/YT to register to win a meteorite, enter the competition to win a meteorite. I am going to be giving out some on the occasion of the Gemini meteor shower coming up. You don't need a .edu email address, but if you have one like me and Avi, go to briankeaton.com/edu, and you'll guaranteed to win one of these beauties sent to your inbox if you live in the United States. I can only do that. And the U.S. could do export regulations. It's slightly radioactive. Avi can tell you all the interesting things about it. I'll bring one to Avi. I owe you a bunch of these babies, Avi. Don't worry, I'll give it to you. Did Joe Rogan still have the Mars meteorite that I gave him? I mean, he kind of,
Yeah,
I
think
was
I
worried
saw
he smoked it.
something.
I was worried that maybe he smoked it or did something to it. I don't know. But
I saw some rock there, but the thing that really surprised me are all these mug shots of people like Mick
Klaus
Jagger.
Schwab. Yeah, Klaus
Yeah,
Schwab. And
all these supposedly criminals that used to be artists, and
yeah.
At the time, of course, what they smoked was banned.
Exactly. Okay. So, Avi, we're going to take audience questions. Please, if you're a member of the channel, drop a question in the chat, the live chat. We'll take some of those. But I want to ask you just a human question as a friend of yours. We've had these two encounters with objects, Oumuamua and now Atlas. Which one, if I could, kind of put you on a Bruckheimer movie and send you out to one of these, which one fascinates you the most? Which one would you most like to visit, and why scientifically is it the most interesting to you?
I would love to visit both, but Oumuamua to me is more puzzling because there was no evidence for dust or gas around it, and yet it was pushed away from the sun. And 3 years later, the same telescope in Hawaii discovered another object that was pushed by sunlight, and that was 2020 SO. And that turned out to be a rocket booster that NASA launched back in 1966. And since then, we discovered a lot of space junk, things that we produce that are floating in space and were mistaken for rocks for a while. That there are 24 of those examples that the Minor Planet Center cataloged as asteroids, and they ended up being actually space junk. So the reason we identify those as space junk is simply because we produced it, and we know what we produced since the 60s. However, if someone else produced something, we would argue that it must be a rock. Why? Because we don't know the properties of that thing. So Oumuamua, in my mind, could have been something like that, and just a thin layer that was produced as part of something else. And I would have loved to come close to it. That just take an image, or even a radar image of it, or of 3i Atlas. If any of them has buttons on it, I would love to press a button.
What do you think is the most likely explanation for the claimed data from the Palomar plates, which are, 75 years old now? I mean, some of these things, I have some of them from Margaret Burbidge, your colleague, my colleague and friend here, a renowned astronomer of all human history. She left me some of her plates from Palomar, which is just incredible treasure that I'll keep to my dying day and maybe pass on to my grandkids.
Yeah, so I would worry about defects in those plates. And these were photographic plates, and they could have had defects, and these defects could have been clustered. These defects could have appeared in regions of the plate that are, by chance correlated with the shadow of the Earth. Who knows? So that's the first thing I would check. And of course, if there was evidence from two telescopes of a single object seen, then of course it's beyond any doubt, because the chance of both of them having the same defect in the same place at the same time is very small. But just having data from one telescope is not immune to defects, and the defects may depend on the level of illumination.
So what are the sort of chromatic effects, perhaps? These are old, archival, they've been stored and not always taken good care as the ones I take care of from Margaret. But what other effects do they degrade? I mean, these are glass plates with photographic emulsion onto them that then have to be scanned, digitized, and so forth, and then looked at under a microscope. And only some of that's been done. I mean, as far as I know.
So in fact, that's exactly what was done for the Harvard plate stacks.
Yes.
And Josh Grindley led this project where they were digitized with a camera. And so we have a digital archive of the Harvard plates.
Do
And
you have that date, that same date in October or whatever,
well,
July?
that's exactly the question that I asked Josh today, and he will look into that. So he will look at the time tag and the coordinates of the events that were claimed to be associated with these glints, and see if his data overlaps in any way or rules out. I mean, so it could either rule in or rule
Yeah.
out the reality of those identifications.
So people are asking about the strange confluence of events. Some of my channel members are asking about the mini moon that was discovered.
Yes.
The also the obviously Beatrice's work with her team on the Palomar day, all this, and Atlas, and then there's two comets that are naked eye comets. Is there something, harmonic convergence aside, Avi? What do you make of all this? Is it just that we're getting
Right.
better and social media is spreading information, good and bad, but also spreading? I took a beautiful picture of Comet Lemon the other night, and I took a picture of Comet Swan. It looked very green and unusual. So what do you make of all this interest in these extrasolar or extraterrestrial objects, at least?
Well, these things happen all the time. It's just like going to a party where you find people independently speaking about other different things, different conversations and different things happening at the same time. So in the sky, in space, there are lots of things happening at the same time, and we might not be aware of that, but now we have better instruments to survey the sky, so suddenly we see a lot of things at the same time. And of course, the Rubin Observatory will give us a sense not only of our immediate neighborhood, but also what happens in the galaxy at large, in the universe at large, all kinds of transients that were never seen before. So we will have a survey of the southern sky every 4 nights, and we just need one for the northern sky. So the existence of a lot of events is not surprising to me. They happen all the time. There is nothing anomalous about them out there. With respect to the second moon or quasi-moon, the claim is that it's a member of a family of rocks that was found to sort of move around the sun and every now and then come close to the Earth. I found it interesting that this particular moon that was, or not moon, but quasi-moon that was identified in August 2025, this August, is actually was close to Earth since the 1960s. And to me, that raised the possibility that it may be one of the upper stages of the missions that were launched in the 60s. So in fact, in 1964, the first mission to Venus was launched by the Soviet Union. And we checked the trajectory, and it's not very different from this object. There are some differences, but in principle, you can imagine having one of these space relics from the 60s appearing as if it's close to Earth just by the fact that it was launched from Earth, in the 1960s. And so we looked into that, actually, and I wrote an essay about that. But it's not a conclusive identification. For 2020 SO, this object discovered 3 years after Oumuamua, the realization that it is technological was based on a spectrum that was taken in the infrared of this object that discovered the spectral features that indicate that it's made of stainless steel. So they saw the signatures of stainless steel, and obviously a rock would never show that. So that's the benefit of taking a spectrum that reveals the composition of the surface of the object.
Some of my audience members that are kind enough and generous enough to join the channel are asking questions about the propulsion structure that would be necessary to close the gap and actually come and make contact with it, which made me think of Elon Musk. And I'm curious. I've talked to him briefly on this channel about a year and a half ago now about his dream to die on Mars. Hopefully not on impact. We want him to die at a ripe old age. So I looked up on Grokpedia. I don't know if you encountered Grokpedia yet. It's kind of
I can imagine, yeah, what
Yeah,
it
yeah. So,
is.
so I looked up Oumuamua, and of course, you can look up anything on Grok, and it'll tell you what you want to hear. But this question of, kind of like you have an hour with Elon, he's a smart guy, knows a lot about the rocket equations and so forth. What kinds of things would you need, to get either? Would you want to catch up to Three Eye Atlas? Would you want to? I mean, think big, Avi. What's your wish list? Go to Oumuamua, or have a series of sentinels, along the lines of Arthur C. Clarke, my protege, my forerunner, monoliths, sentinels. What would you have on your wish list for our friend of the show, Elon Musk?
Yeah, so if we wanted to reach 3i Atlas, we would need a rocket that is at least 3 times faster than the ones we have. We can't do that. It's not practical at the moment. I would say let's prepare for the next one. And with the Rubin Observatory, we should find a new interstellar object every few months. So, but we need to be prepared. We need to have a plan for an interceptor. So we need to deploy it potentially at a Lagrange point around the Earth or somewhere else in an orbit around the Sun, so that it will be able to catch up with a future interstellar object. And the earlier we detect an interstellar object, the better, because then we have more time for the interceptor to move into the path of this object as it comes closer. The European Space Agency has a project called the Comet Interceptor. But the problem with that is they are capable of a velocity kick of 2 kilometers per second. That's what they assigned to the fuel that they put on the Comet Interceptor. The design is allowing only 2 kilometers per second boost. That's not enough, because interstellar objects are coming at tens of kilometers per second. So unless we are lucky, like in the case of Juno, I mean, in the case of Juno, 2 kilometers per second would have been sufficient, but it doesn't have the fuel with it. But what we want is an interceptor mission that has more fuel, so that it can maneuver at the level of 10 kilometers per second and get to the right time at the right place. And that is something that needs planning and an investment. And and the investment may be at a level of $1 billion or so, and in preparation for the next interstellar object. And I think the benefits are great, both for science and also technology, if we are able to do that, because we can then learn a lot about the nature of the object, and how we can mitigate any potential risk if it happens to move
Yeah.
closer to Earth. Yeah.
So some of my members, again, you could join the channel as a member for 99 cents a month. It lets me know you guys care about it. Otherwise, we try to keep these minimal sponsorship, at least with, except for YouTube's algorithm, which you can get around if you pay YouTube $19 a month, but as I do. Someone's asking, could Three Eye Atlas, probably not, but could other objects, maybe the type that Beatrice saw, could they be Earth artifacts? Could they be ejecta? Kicked up as we have here, as I gave to Joe Rogan, a fragment of Mars and the moon. Here's a fragment of the moon that came from an impact on the moon that sprayed out and landed on Earth in Northwest Africa. Tell me, could any of these objects she saw, maybe these other objects, could they come plausibly from the Earth in its distant history?
No, not really. I mean, obviously, you can produce an interstellar object from the Earth, and we have a demonstration of that in the form of Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons. They are made of materials found on Earth, and they were launched at a speed high enough so that they will exit the solar system and become interstellar in about 10,000 years, once they exit the outskirts of the Oort cloud. That's at a distance of 100,000 times the Earth-Sun separation. So there is a proof of principle that if you launch something fast enough, it can actually exit the solar system and become interstellar, but it will never come back. So what we see for these objects is not an object that is marginally bound to the sun, so it goes out and then comes back. It's an object that just comes into the solar system with a high speed. In the case of 3i Atlas, the speed is huge. It's 60 kilometers per second outside the solar system, which is twice the speed of the Earth around the sun. And so there is no way by which we can produce such an object from the solar system. It had to come from outside. That's why we call it interstellar. there is, of course, some people try to suggest that maybe Oumuamua came from a collision in the outer part of the solar system. That's because Oumuamua was just, almost at rest relative to the local standard of rest of the Milky Way galaxy. It simply, the solar system bumped into it. But the chance of a collision of any objects in the outer parts of the solar system is minuscule. There is no way that we could have gotten an object like Oumuamua or especially 3I Atlas this way.
Very good. Okay, last couple of questions. One is, you mentioned the prospect of both Pascal's wager and Trojan horse, kind of not wanting to repeat the Trojan horse affair. What are the odds of these different things from your perspective? That could be a Trojan horse. Is it dangerous, perhaps? And then later I'll ask you, what it would take for you to stop discussing these types of objects? People are curious about, do you have a price? Is somebody, putting you up to this, Avi? But we'll get to that, the final question. But first of all, is it a Trojan horse? How would we know, and what could we do about it in that case? And it brings up Pascal.
Right. So broadly speaking, a Trojan horse is something that has an appearance that is friendly, that is not suspicious in any way, but an interior that is potentially harmful. And in the context of what I'm discussing, the interior could be technological. So imagine hollowing out a comet or an asteroid, and the inner part of it is actually technological. The outer part, the appearance of it, is just as if it's a natural object. And this is a very comfortable way of passing through planetary systems and not raising any doubts that the object might actually be a Trojan horse where there are soldiers inside of it. Now, how do we figure out whether it is or not? Well, first, if we had a way of measuring the mean density of the object, a hollow object would have much less mass given its size. And in principle, we can measure the mass of an object. For example, when we will have the next generation gravitational wave detectors, they would be sensitive to massive objects passing through the inner solar system. So probing the gravity of the object would be a great benefit because it will tell us whether there is a hollow object. Another way to tell is if there is an engine, there would be excess heat being produced beyond what the solar radiation is warming the surface with. So that we know the illumination, how much power per unit area is deposited on the surface of an object, depending on its distance from the sun. But if it emits in the infrared excess heat, that may come from an engine. And of course, there could be artificial lights that we detect that have nothing to do with sunlight. And so we should observe the object in the infrared. And as long as we can resolve it, we can distinguish between the plume of gas or dust around it and the nucleus. So these are ways to tell the difference between a Trojan horse and a completely innocent, in our case, a piece of rock. If we could measure the mean density or the mass of the object. And if we don't detect, if it walks like a duck and it quacks like a duck, it's a duck. I have no problem with that. And as long as, like, if, for example, this object breaks up and we see that it's, all of the pieces look just like the pieces of a natural icy object that is made mostly of carbon dioxide, so be it. That would clear the ambiguity we have.
Well, Avi, the final question touches upon this very rare quality that few human beings have, and that's courage. People want to know, will you stop looking at this? If people came to you and they, were curious in what they could do to make you stop looking into these things, asking these questions, being a critic, holding up a mirror, holding up a spotlight on these objects, are you going to stop? And what's in it for you? I mean, they do accuse you. I've been accused of it. Our friends have been. Grifter. I don't even know what it means. I mean, are you getting paid by big NASA? I mean,
no.
First,
how
do you respond to the accusations that you're a grifter, Avi? I mean, even Joe Rogan, when I was on, he wanted to kind of bait me into say stuff, and I didn't take the bait. But what do you make of that accusation? And then what would it take for you to stop and just be quiet, Avi? Stop asking questions.
Well, the point is that that's the whole idea about doing science at the frontier, trying to figure out something that we don't know. And there is a huge amount of enthusiasm. I just received 51 watercolors and 2 bronze sculptures of Galileo Galilei donated to my office last week by the most accomplished sculptor in the United States called Greg Wyatt. And in 2 weeks, we will do the unveiling of those amazing pieces of art. And they are all in my office. Extremely expensive stuff. This is my office is now a museum, and I will not charge anything for anyone that comes into my office. But just think about the generosity of this sculptor, the artist, to make the 51 watercolors. Each of them took him several days to weeks, to make, because it's stippled. He made them out of dots, and he decided to donate all of that. He framed it at no cost to me. He just gave it to me as a generous gift, being inspired by my research. There is a singer in the United Kingdom that his manager contacted me, Ollie Swan, that he has a song coming out next month called "The Aliens Are Real." He was inspired by what I do, and they wanted a quote from me about the song. I heard from a pilot of the U.S. Air Force, a former pilot, that he said that because of you, my daughter decided to become a scientist.
Wow.
And I actually corresponded with her because I mentioned her name with Joe Rogan, and she told me just an hour ago that because it was mentioned Joe Rogan, then the principal of the school that she goes to, they announced it to the entire school, and that she was very proud of that, and she wants to become a scientist. So that's amazing, how. And then a reporter of the London Times wrote a report about my work, and he read it to his kids, and they said they want to become scientists. So I see that all over. When people tell me now, we realize that science is exciting. And the fact that I'm attacked personally is irrelevant here, because I'm serving a very good purpose of bringing people to appreciate science. All those other, commentators that say they know the answer in advance, they don't inspire the public. And this is a subject the public cares about. The public funds science, so we have a duty to explain to the public why science can be interesting, and because it's a work in progress. We shouldn't say that we know the answer in advance. Now, those people who are trying to derail what I'm doing, they will go far and beyond what sounds like a professional behavior. And I don't want to mention specific details, but they really are trying to throw as much mud as possible in all directions. I regard that as mud wrestling, and I don't want to get dirty, so I don't engage with them at all. But they're doing really unprofessional and very dirty tricks, and I just ignore that. I think that this is part of the scientific process, that a lot of people are inspired much more, by factors of several orders of magnitude. More people find it inspiring than those that are doing it because of jealousy of the public attention. As long as the subject didn't get public attention, they were perfectly fine with it. And the strange thing is that some of those mud wrestlers are people who advocate for SETI, for the search for radio signals. However, they have a problem with the search for technological signatures in objects coming to the solar system, and I find that really strange. Why would they do that? And they still do that. But it doesn't matter to me. You see, I don't have a footprint on social media. Joe Rogan said, thank God for that. And I said, don't thank God, thank my wife.
Yeah, that's right. Well, explains your productivity as well. And I just want people to know, if you come after Avi, you're coming after me. If you come after my hyperscanadium alien artifact that Avi gave me, you'll have to pry it from my cold dead hands. Avi, what's the next major event for this object, Comet or not, technology or not? When's the next major event that we can schedule in the next conversation?
Oh, okay. So next week it comes. It will be observable to the JUICE mission of the European Space Agency. It will be observable. We'll get some data hopefully a few weeks later, but next week it will be seen by JUICE. And that is very important because we can tell if it deviated from the trajectory that we anticipated. And then after that, it will be the December 19th date, which is 6 days before Christmas. And my hope is that it will not send any gifts on that at that time. That will be the time when it's closest to the Earth. It's also around Hanukkah. Right. And so
I don't have any money left. You told me to sell my whole portfolio, Avi. I've got no gifts for Gelt even. My Gelt is gone, Avi. But Juice is a NASA mission, so we probably won't hear anything next week, right? But so let's plan
no,
on
it's an ESA mission.
ESA. So, okay, so there's some NASA.
So the thing is that they are using the communication antenna as a shield from the sun, so they won't be able to transmit the signal after getting it in the first week of November. They'll transmit the signal probably a few weeks later. So we will just have to be patient. But then on December 19th, we can observe it from Earth. There are 242 observatories already that looked at the 3 Atlas. That would be the best time to look at it. Also, if you have, if you are an amateur astronomer, you can use your big telescope to look at it. So that's when I hope to get as much data as possible. And then eventually it will come close to Mars on March 16th, 2026. So that's when the story will probably fade away. If it continues along its path and it looks just like a comet, then it's a comet.
And that's so important. Sorry, Avi, I want to end there because what Avi just said is the mark of a good scientist. And I taught many scientists, not as many as Avi. I've written the square root of the number of papers. I have the H index, that's the logarithm of Avi's. But I recognize a good scientist when I hear it. And what he just said is a testimony to what you need as a scientist, Avi. I always say you got to have chutzpah because nature is undefeated. Nature will crush you if you have arrogance, if you have haughtiness, but like some people do that we started off the conversation, perhaps, I don't know. But you have to have humility. You have to have these two pockets. In one, it says you are made of nothing but dust and ashes. And the other one, you say the whole universe is meant for me to explore and be inspired by. Avi Loeb, thank you so much. I got to run, and we'll talk in a week or 2 weeks, perhaps, and we'll get a next update on this fascinating object. Thank you for doing so much to inspire young people, old people, and professionals and non-professionals alike through a combination of envy, jealousy, and just imagination and passion about what you do. Thank you, Avi, my friend, and I'll talk to you soon.
Thanks for having me.